little bit of section 4 done. But for now, I'm going to make sure that we at least finish section 3. So for section 3, we're talking about modified box and whisker plots. How many of you remember making box and whisker plots in a previous class? A few of you? Okay. It's interesting. It used to be much more. I don't know if that was something that got cut out earlier, but typically we're doing there's one new thing that we add on. So if you've done box and whisker plots before, we're going to add a little bit to it. If you've never done a box and whisker plot before, that's okay. We'll go over it right now. So let's take a look here. A box and whisker plot helps us visualize how the data is spread out. So like standard deviation describes the spread of data, a box and whisker plot kind of shows you where the data is, how it's concentrated, where there's more data points and where there's less. So here we go. For the first set, anytime you find a box and whisker plot, you're going to find 5 numbers. We're going to call it a 5-number summary. You have to find that first before you make the box and whisker plot. So right now we've got a set of numbers. We're going to find 5 important numbers out of that. The first one is the minimum, the smallest number. So in this case, 0. That's my minimum. Nice and easy. We're also going to find the maximum or the highest number. You can call it whatever you want. I'm going to go ahead and call it maximum right now. I know that down here, this table says high. You could change that to maximum. Might be better just to be consistent there. The median is the middle number, right? If you, again, some of you have already done your driver's training, talked about the median of a road. Literally the barrier that goes down the middle of the road is the median. So in this case, for a set of data, the median is the middle number when they're in order. So for this one, I have 7 numbers. If it's an odd number of numbers, I'm going to have one right in the middle. So in this case, it's the 5. That's my median. Does that make sense to everybody? Now, for the second part, here's where we have some issues. For most people, minimum, median, maximum, that's nice and easy. But now we're going to find what's called quartile 1 and quartile 3, or Q1 and Q3. And there is a trick to finding these that if you're not paying attention right now, you may miss. So when you're finding Q1 and Q3, you're going to split the data into the lower half and upper half. You do not include the median, okay? The actual median does not get included. So in this case, the 5, I'm going to leave it out of this. That's going to be my lower half. This is going to be my upper half. The 5 doesn't go with either of those. So now 0, 2, 4, that 2 right here, that's the middle of my lower half. That's my Q1. That did not come out as a Q. Q1. For this upper half, the 6 is the middle of the upper half. That's my Q3. Now, often I have people asking, what happened to Q2? Q2 is the median. Does that make sense? So you get minimum, Q1, Q2, Q3, and then Q4 would be the maximum. So these 5 numbers are what we're going to use to make our box and whisker plot. So I'm going to draw just kind of like a number line here, going from 0 to 9. Let's go from 0 to 10, just so we've got a little bit extra there. So 0, 1, 2, 3, 4. Try to make it evenly spread out if you can. 5, 6, 7, 8, 9, and 10. So I'm going to put points down here. Minimum is 0. Q1 is 2. And we can label these. Minimum, Q1. Median is 5. There's not quite enough room for me to label this all nicely. I'm going to move that Q3 up a little bit to give myself some more room. So this would be the median. 6 is my Q3. And 9 is my maximum. Once you've got those 5 points, the box and whisker, the box goes around Q1 and Q3. Okay, it goes around the middle 3. So from Q1 to Q3, this is my box. The median is kind of a dividing line that cuts the box into 2 parts. The whiskers go from the box down to the minimum, which I apparently erased the I, and up to the maximum. There's my box and whisker plot. Now, what does a box and whisker plot represent? It's supposed to represent the quartiles, which means the fourths of my data. So I have 5 points. That means 1, 2, 3, 4 sections. Does that make sense? 5 points, 4 sections in between those. Each section should be 25% of my data. So 25% here, 25% here, 25% there, 25% here. So you can tell that some sections of the data are more spread out than others. Want to make sure, again, everybody, phones away. Make sure you're focused during this lesson, all right? So can everybody see that then the box represents the middle 50, right? The box is going to be the middle 50% of my data with 25% below, 25% above. Any questions about how we made that box and whisker plot? Okay, let's knock out another one real fast. This next one, I have minimum is 10, maximum is 18. My median, though, I've got a problem. 1, 2, 3, 4, 5, 6, 7, 8. If I have 8 numbers, I don't have a middle. Does that make sense? If you don't have a middle number, you're going to take an average. Get the middle 2 numbers. So in this case, 14 and 15, and average them. 14 plus 15 divided by 2 gets me 14.5. 14.5 is going to be my median. Now, because that was not a number in my set, it was an average, it doesn't get used in the lower half, but the 14 does. So that's my lower half. This is my upper half. Because my actual median value, I had to make up. Does that make sense? It was in between those 2 numbers. It doesn't get included in the lower or upper half, but the 2 numbers that I used, one goes to the lower one goes to the upper one. Now, in this case, I have the same problem again, because I'm looking for a median value of my lower half, and there's 4 values. So I once again have to take an average. 12 and 13, the average would be 12.5. Whereas for the upper half, 15 and 17, the average there is 16. So that one's a little bit nicer. Ends up being a whole number. But once again, I have all my values, minimum, Q1. Let's label these Q1, Q3. I can now put these on a number line, make my box and whisker plot. So it looks like I'm going from 10 up to 18. So here's 10, 11, 12, 13, 14, 15, 16, 17, and 18. Minimum was 10. Q1 was 12.5. Median was 14.5. Q3 was 16. And the maximum was 18. So box goes around the middle 3. Line through the median. And then whiskers out to either side. Does anyone have any questions about how we did that? So now that might have been something that you've done in the past. In a typical year, I usually have like half the class say they remember how to do that. But again, could be something that they're starting to not do as much in junior high now. The next piece is the new part, hopefully, probably for everybody. We're going to do what's called a modified box and whisker plot. So the issue is sometimes you have values that don't represent the data well. So this class, if we took the average of your ages, might be around 17. If we take the average of our ages and we add me in, it's going up to 17 and a half or maybe 18. Does that make sense? I mess everything up with my age. I don't match everybody else. There's a good chance that I'm what's called an outlier. It's a point that doesn't match the pattern of all the other data. We want a way of identifying that so that we can leave it out when we're collecting data. Does that make sense? Or trying to analyze it. So we're going to find what those outliers are. And there's a very specific formula to do that. We're going to find an upper boundary and a lower boundary. Anything outside of that is going to be an outlier. Essentially, those boundaries say anything inside that's close enough to what the other numbers are, that we'll keep it. Anything outside is too different. We're going to exclude it. So for the upper boundary and lower boundary, the pattern's kind of the same. To find the upper and lower boundary, you have to find what's called the interquartile range. The interquartile range is literally the width of the box. How wide is the box of your box and whisker? Width of the box, which the formula for that is Q3 minus Q1. Q3 minus Q1. So again, this is the formula for finding the IQR, Q3 minus Q1. Now, every year I get people asking me this question, so I'm going to try to head off the questions. We're going to multiply the IQR by 1.5. Always 1.5. That's the question people always ask. So the idea is we need to draw a boundary. We need to say something is too far. And so what they've decided is, here's the width of my box. I don't just want to go that far. I want to go 1.5 times that. They extend it a little bit out. And they say anything past that, that is just too different than everything else. Why 1.5 and not 1.75 or 2? I'm not really sure. I think they just decided this is a good representation. If this is my box, a little bit more than that distance above. But it's always 1.5. Okay? That's the standard. That's what they decided. That's the limit for this. So it's always times 1.5. The other issue here is the IQR is that width of the box. When we multiply it by 1.5, that does not have a name. That's just the number we're going to use. Does that make sense to everybody? If they ask you for the IQR, it's Q3 minus Q1, but then we actually multiply that by 1.5 before we plug it into our formula. So for the upper boundary, that number, once I multiply it by 1.5, I add that to the top of my box. So I'm going above the top of my box. For the lower boundary, I subtract it from the bottom, from Q1. Often, I have students that pick one or the other, and they just keep the same point. So they maybe go above and below Q3 or above and below Q1. That's not how it works. You take the box, you go above the box and below the box. Does that make sense to everybody? And again, it's all listed right here. What I'm saying is this exact description. Anything outside of the boundaries is an outlier. We don't connect the outliers with the whiskers. Instead, we find a substitute point, another one that's inside the boundary, whichever point is the next highest or next lowest. So let's try this. We are going to, any outliers, we're going to cross them out. We're going to make a little X where they would have been. But let's try it. So turn to the next page. Question 1, make a box and whisker plot for the set of data. Check for outliers. To be clear, the 5-number summary doesn't change. The 5-number summary is what it is. It's only when we're drawing the box and whisker plot that we cut out the outliers. Okay? So let's find our 5-number summary, the 5 important points. 20 is my minimum. 55 is my maximum. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 numbers, it's odd. There's a middle. 1, 2, 3, 4, 5 right here. 1, 2, 3, 4, 5. That's my median. There's a test question that's going to ask you if you have 28 data values and this is your median, is that necessarily a number in your data set? Does everybody understand that if it's an odd number, that median is a number in my data set? If it's odd, that is a number that I have. If it's even, it's going to be an average. Does that make sense? So that number, that median, isn't necessarily in my data because it comes from the average of these two. That will show up several times, both in our review and on the test. And it should be an easy question as long as you remember odd, it is in my data set. Even, it doesn't have to be. It's an average. So we've got those. Here's my lower half of the data. Let's try that again without cutting through it. Here's the lower half. Here's the upper half. Why did I not circle the 26? It's the median. It's in the exact middle. It doesn't go with the lower or upper half. But now, the lower half, 22 and 22, the average of those is 22. That's kind of nice. That's easy. 29 and 31. Average of those is, 29 and 33. Average of those is 31. Does that make sense? So for each of those, the four, those are both even. I had to take an average to get the middle. Now, I'm going to go ahead and draw this in on my axes, on my little graph here, and then I'm going to check for outliers. So these points, I'm going from 22 to 55. So let's try, I think I can do fives. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and that covers everything that we need. So right now, I have my minimum at 20. Let me go ahead and put a little point up here, and I'll call that, again, this is my minimum. 22, let's use some different colors here. 22, that's my Q1, and I should maybe label that because it's not on a line. So 22, that's my Q1. 26 would be right here. That's my median. 31 up here. That's my Q3. And then my maximum right now is 55. Put that way up here. Now, even just right there, is there one of those points that looks like it's far away from everything else? Sometimes it's pretty easy to figure out where that outlier is going to be, but we want to calculate it. We want to check. And I forgot to mention this, on the previous page, it specifies if it's on the boundary, it's okay. On the boundary is fine. It has to be past the boundary to be an outlier. So I need to figure out where my boundary is to see, is that 55 too far away from the rest? Now, the IQR, the interquartile range, is the width of the box, Q3 minus Q1. So here's my box. I'm going to find the IQR by doing 31 Q3 minus 22, which is Q1. 31 minus 22. 31 minus 22, the width of my box. My width of my box is 9. And now, what do I multiply that by? 1.5. We have to memorize that. 1.5 is what you multiply the IQR by. So 9 times 1.5 gets me 13.5. Again, you can use a calculator for that. 9 times 1.5. Get your answer. I'm going to add that to the top of my box. So 31 plus 13.5. 31 plus 13.5 is going to be 44.5. So right up here, you add it to the top of the box, Q3. This right here is my upper boundary at that 44. This is kind of, let's clean that up a little bit. So this equals 44.5, and that's my upper boundary. Is the 55 outside my upper boundary? Yeah, like by a lot. So I'm going to cross it out. It still needs to be on my graph, but I'm going to have a little X where it was. We're saying that point is too far. It was a part of my data set, but it's too different than everything else. Now, I have to go back to my data set and find the next biggest number. The next biggest number is 33. So I'm going to put that in here. Actually, it should be even like right there. 33. That's going to be my whisker. Instead of going all the way up to 55, I go to the next biggest number. My lower boundary is going to be Q1, so 22 minus 13.5. 22 minus 13.5 gets us 8.5. My lower boundary is actually off the graph. It's over here. 8.5 down here. So just show it's right there. 8.5. I don't have any numbers outside of my lower boundary. So this one, still my whisker. How are we feeling about that? Find your 5-number summary, find the upper and lower bounds, and see if your points lie outside of that. If they do, cross them out and find a substitute in the data set. Find the next highest or lowest number. Then draw your box and whisker plot the rest of the way. Does everybody understand that the box can never be cut out? Because literally the definition of the upper and lower boundaries is the width of the box times 1.5 above and below the box. So the box is always going to be fine. It's just the minimums and maximums that might be outside and our outliers. So let's do another one. Here we have what's probably the hardest part of today's lesson, putting these numbers in order. Because does it make sense that the box and whisker plot makes no sense if the numbers aren't in order? It's all about the order of the numbers. So I need your help right now. We're going to go through this. Make sure that we don't accidentally miss one while we put these in order. So here's what I would do. I would try to line them up or write them in the same like spacing. Find the lowest one. Looks like the lowest is 2. So I'm going to start with a 2. Then I see a 10. I'm going to try to line them up so I know if I miss one. We've got 11s, 2 11s. Yeah, I think we have a 12 right down here. 2 13s. Got a 14 and a 15. 16. A 17. 2 17s. No 18s. Got a 20 and a 35. All right. So there's my data set. It's all in order now. Now I can find the minimum. 2 is the minimum. Maximum. Median, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is this data set going to have a median, like an actual number in here? No, I have to find it. I have to make it. So I'm going to find the middle two. So that's 1, 2, 3, 4, 5, 6, 7. Right in here. 13 and 14, halfway in between those two, is going to be 13.5. Again, add them up, divide by 2. 13.5. From there, I'm going to go ahead and look at the top and bottom sets, the top and bottom halves. Do I include the 13 in the bottom? Yeah, it's not on my median. It gets included down here. And then I have an upper half right here. So with 7 in the lower and 7 in the upper half, I'm going to have actual middle values, right? 1, 2, 3, 4. 11 is going to be my Q1. 1, 2, 3, 4. 17's, what's up? For which unit? So I have to print some more. I'm all out. Sorry. I'll have some on tomorrow or on Friday, or you can even stop by this afternoon. You're welcome. Sorry about that. So 17 is going to be Q3. Does that make sense? We've got our numbers. I'm going from 2 to 35. So let's go ahead and count by fives again. Let's go. I'm going to move it to the middle here. 0, 5, 10, 15, 20, 25, 30, 35, 40. So we've got all those values. You could actually find the IQR right now. You don't have to graph these. We can just say, okay, my IQR is 17 minus 11. Q3 minus Q1. 17 minus 11 is 6. That's my IQR. And now I multiply it by 1.5. Remember, the 6 is my IQR, but I don't use it like that. I multiply it by 1.5 first. So times 1.5. 6 times 1.5 gets me 9. That's what I'm going to add and subtract from my box. So let's go ahead and graph the points that I've got right now. So I have 2 right here. I have, and that's my minimum. I have 11. And that's my Q1. I have 13.5. Get in the habit of labeling your points, just so it's obvious what they are. 13.5, which is my median. I have 17 as my Q3. And I have 35 as my maximum. So right here, this is my box. Around the middle 3. There's my box. Does that make sense to everybody? You're doing okay? So now we're going to go above and below by 9. So Q1, 11 minus 9 is 2. That's my lower boundary. Let's use a different color there. 11 minus 9, 9 below 11, that's 2. Right there. That's my lower boundary. Is that point okay? It just squeaks in, right? It's on the lower boundary. And we said the lower boundary and upper boundary are fine. You have to be past them. So if I do 17 plus 9, that makes 26. Here's my upper boundary at 26. 35 is definitely outside that. Does that make sense to everybody? Up and down is yes, side to side is no. We got our box. The IQR is the width of our box. we're going from my box, 1.5 boxes above, 1.5 boxes below. Anything outside that is an outlier. So again, this distance right here, this was 6. So I go 6 times 1.5 this way, 6 times 1.5 that way. That's the upper and lower bound. So 1 second, let me finish this one. I'm almost done. Now, I can draw my whisker from the 11 to the 2. Where does my upper whisker go? Look at the next highest number, the 20. Every year I have a few students that try to go to the upper boundary, right? But I don't have a point on the upper boundary. I go to the next highest number. What do I do with the 35 out here? Do I erase it? Cross it out, X it out. It needs to still be there because it was a part of my data set, but it's so different that I don't count it when I'm looking at my box and whisker. How do we feel about this? Okay, hopefully not too bad. A little louder. How did I get the 20? It was the next biggest number in my data set. So I crossed out the 35, the next one was 20. Now, can you guys do okay without seeing another example of that? If you want to see it, I did record it this morning with the other class. I'll post that video of this one. But instead, here's what I want you guys to do. I want you all to try the next few problems. Your homework is 1 through 7, but I am going to let you skip 3 because number 3 has a data set of like 40 values and they're not in order. It's a pain to put them in order. So skip 3. You can do it for extra credit. All right. So let's talk about 6 and 7 from the homework real fast. 6 and 7 are conceptual questions. I'm going to do number 6 with you, and then I want you to try number 7. Number 6 says, suppose the Buck Depot, which currently sells 492 distinct items that cost between 25 cents and $1, right? So it's like a dollar store. Everything is $1 or less, 25 cents to $1. It decides to sell an item that costs $5. This kind of question does not work if the number they're giving you is inside the current range. Does that make sense? Do you all notice how 5 is outside of what they're normally selling right now? So the idea is you can actually figure out quite a bit about what's going to happen to your data set when you add a number that's different enough. Remember how we talked about my age affecting the average of the class age? And that the reason we know that is because I'm older than everybody else. I'm outside the current range. And so it's easy to tell what my age is going to do to everything. It's going to raise it all up. It's going to make it bigger. So here, does it make sense to everybody that when I add that 5 in, it's going to raise the average? Does that idea make sense to everybody? That if I add something bigger than all the others, it's going to make the average go up. Whereas if I added one in the middle, it'd be hard to tell. Technically, if you add a number that's bigger than the average is right now, the average goes up. If it's smaller than the average right now, it goes down. But I don't know what the average is. But the average has to be between 0.25 and 1, right? There's no way for the average to be bigger than 1. And that 5 is way bigger than the average right there. So when I add that in, the mean has to increase. There is no other option. The median is the middle number. The median is the middle number. Now, we have to be a little careful with this one. Do I know what the median number is right now? Am I going to have items that cost the same amount at this store? Right? There's 492 items. There are not enough numbers in between 0.25 and $1 for them all to cost different amounts. Does that make sense? So right now, I don't know where the median is. And it very well could be that the median could be right next to a bunch of other numbers that are all the same. right? Let's say that maybe the most common price is 50 cents. Maybe they've got 100 items that are 50 cents. That could be the median and the one next to the median and the one next to the median and so on. When I add the 5 in, it's going to shift my median up. Does that make sense? It is going to move it, but there's a good chance that it might not actually change it because the values, it all depends on what's right there in the middle. If it's 50 cents and the one next to it's 50 cents, and it might not change. Or if maybe it happens to be at 50 cents right now, but the next item is 52 cents, and I'm having to take an average, I don't know what's going on with the median. I don't have enough information here. Does that make sense to everybody? I would need more info to be able to figure that out. Now, that being said, is there any way that the median would go down? There's no way for the median to go down. It could stay the same. It could go up. I don't know which, because I don't know what numbers are actually in the middle. The mode. Anybody remember what the mode is? Yeah, the one that happens the most. Does that make sense to everybody? So if this is like a regular dollar store, maybe everything, the most common is $1. Most things cost $1. Is my adding that 5 on there going to change it? No, whichever one's the most common is still the most common. Does that make sense to everybody? That one's going to stay the same. Even if there wasn't a mode, which in this case, there's got to be a mode because we know we have some repeats. But even if we didn't, even if we had fewer items and there might not have been a mode, it would still not be a mode. It's not going to change when I add that $5 in. Here's the one that confuses people. The standard deviation. Is my data more spread out? Right? This is what it was before. Now it's this. It's more spread out. Does that make sense to everybody? The 5 is spreading my data out farther. If you add something outside of the normal range, your standard deviation goes up every time. You can't add something and have less spread out data if that number is outside what we already have. So with that in mind, the median is going to almost always be cannot be determined. Unless they really tell you more information, you're not going to be able to tell what's going on with the median. The standard deviation will almost always go up. It's the other two, actually, and even the mode is going to stay the same. Really, the only one that you're not sure about is the average. Does that make sense to everybody? Literally, you could just remember, median can't be determined. Mode stays the same. Standard deviation goes up. The only thing you have to figure out is if the mean go here, does it increase or does it decrease? That's really the only one that has an option. Can you all do number 7 now? Yes.
How would you know if the mean
If the number that they added in is smaller than the rest, the average will go down. Does that make sense? If I bring my 4-year-old in here and we average everything in with my 4-year-old, the average is going down. Does that make sense for age? Let me stop the recording here.